Right, we're looking at circles again, and we're looking at the relationship with tangents to circles. So remember, tangent to a circle is a line that just touches the circle at one point, okay? So it just skims the circle like that, okay? This, not a tangent, touches the circle at 2 points, okay? This, not a tangent, nowhere near the circle, right? So it just touches the circle at 1 point. Here is the key thing that you need to know. If this is the center of the circle, and we drew a line from the center to the point of contact, that will always make a 90-degree angle, right? So, important bit of information. If that's the center, that's the point of contact, it will be 90 degrees. So if I drew another tangent up here, that's the point of contact. I drew a line up. Doesn't look like it, but it should be 90 degrees because mine's not a circle, right? If I drew another tangent here, that's the point of contact. It makes 90 degrees. So that means when we have problems involving the tangent, or a line that just touches a circle, we know that the perpendicular distance, remember that formula? The perpendicular distance, a times x1 plus b times y1 plus c all over the square root of a squared plus b squared. So you need to be very familiar with this. Once you see the tangent, the distance from the center to that line will always be the same as the radius. Okay? So that's the important bit of information. What I'm going to do, I'm going to do a few questions with you as an example through an exercise, and I'm going to let you have to practice them, right? So page 433. Question 2 says we have a circle, x minus 3 squared plus y plus 4 squared equals 50. And we have to show that x minus y plus 3 equals 0 is a tangent. Okay? So to show it's a tangent, we need to show the distance from that line, to the center of the circle is the radius, which is given here, isn't it? Because we know the center of the circle is, so center is 3 minus 4, and the radius is equal to square root of 50. So we must show that the distance from 3 minus 4 to that line is square root 50. So a, b, c, a equals 1, b equals minus 1, c equals 3. Remember, we've got the general equation of the line. This is x1, this is y1. So a x1 plus b y1 plus c, the modulus of all over square root of a squared plus b squared. We're going to work that out. Hopefully we get my square root of 50, then we've done the job. So 1 times 3 plus minus 1 times minus 4 plus 3 all over the modulus of that, all over a squared 1 squared plus minus 1 squared. So the bottom is, that's square root of 2. Let's look at the top. 1 times 3 is 3. Minus 1 times minus 4 is 4. So 4, 5, 6, 7, 8, 9, 10. So 10 root 2. Let me just check down the calculator. Yeah. So if you check in the calculator, don't be alarmed if this doesn't equate to that, right? So if I go on my calculator now, I do square root of 50 equals, so that's 5 times root 2. We can do this using surds, but I won't get into that now, right? We can prove that using surds. So then we go 10 square root 2, that's also equal to 5 root 2. Okay? But you know, the other way, yeah, it doesn't matter. Okay, that's the way we've shown that. Right, let's look at question 5. So pause video, have a look at question 5, read through it. I'm not going to do all these with you, I'm just going to give you pointers. So Find the equation of the circle whose a centre 2, 1 and touches the line x minus y plus 5 equals 0, right? So to get the equation of any circle we need the centre and the radius. So we've got the centre, tick, we need to find the radius. Okay, so let's go back to, we've got a circle and a line just touching it, so we need to find the distance from that point to there to get the radius. So that's all we need, because at the moment we can say that x minus 2 squared plus y minus 1 squared is equal to radius squared. That's not good enough, we need to have the radius, okay? Now when you check these in the back, by the way, it'll probably give you in general form, because that's what they generally do, but it doesn't specifically ask. So, you know, if you prefer to use this method, that's fine. Just be careful of the way it's asked for in the question. You can still use this method for general form. You should multiply out this bracket. So x minus 1 squared is x squared minus 4x plus 4, for example, plus y squared minus 2y plus 1 equals radius squared. Okay, so I'm not going to work the radius out for you. You have x1, y1, and you have a line. So x1, y1, you have a equals 1, b equals minus 1, c is equal to 5. So you can use that equation to find the radius. You should be able to finish that, given that we've done that on the previous topic as well. Look at question 7. The wording here is quite new. It says the circle with centre 2, 2, and it touches both axes. So you have to, well, I know you don't have to sketch this, but it's very hard to answer it without sketching. So let's have a look. The centre is 2, 2, so there, right? And what that means is touches. It means the axes are tangents, basically. So I'll just try and sketch it here as best I can. That's what's happening, basically. It's just touching here and there. So we need to find the equation of the circle, but if you think about it, it's quite straightforward. We have the centre, so it's x minus 2 squared plus y minus 2 squared. If you think about it, if it's just touching that circle, that means that distance to there is 2, isn't it? Same as here. That distance to there is 2, because that's the x. So the radius is 2 squared, which is 4. In general form, multiply this out. X squared minus 4x plus 4 plus y squared minus 4y plus 4 equals 4. So I've got x squared plus y squared minus 4x minus 4y. I got 4 and 4, which is 8, minus that 4, so plus 4 equals 0. So I did that one for you. Turn to question 19 there, please.